Now let's have an example of finding the derivative of a function from first principles. So our equation for this is f prime of x is equal to the limit as h tends to 0 of f of x plus h minus f of x over h. Now this function here is not written in a term of f of x. It's written as y. So there's another way that we can write derivatives, which is written as dy dx. dy dx refers to the fact that the function of y is dependent on x. And the d part of it looks at the small changes, the small difference in y with respect to the small differences in x. So this point here is just the same as writing this point here. Now I can continue writing in my formula, which is going to be the limit as h tends towards 0. Now our function of x here and function of f of x is this part here. What we need to do is input it as our x plus h. So wherever there is an x in this part here, we're going to write it as x plus h. We square that, plus 2. And now we've got an x here, so we write that as x plus h. And now we just minus our function as it was, so just this part here. So that's x squared plus 2x. Now be careful that that minus sign applies to everything in the function. So that may change to a negative sign. Now, and we just put that all over h. Now this is the really fun part about doing derivatives from first principles. You have to expand all of this information so that you can then cancel down the h. So expanding this out gives us the limit as h tends towards 0. The x plus h squared here is going to give us x squared plus 2xh plus h squared plus 2x plus 2h minus x squared minus, because we have a positive and a negative, and those together give us a negative 2x. Now we put all of that over h. So now we start simplifying it. We have an x squared here, and we have a minus x squared here. So let's just get rid of those, and we don't have to worry about that. We also have a 2x here and a minus 2x. So let's just get rid of those. Now we'll go through and write this out. So we take the limit as h tends towards 0 of what we've got is 2xh plus h squared plus 2h on h. Now we can simplify this again. We've got h is in every single section, so we've got an h here, an h here, and an h here, and an h here. So we can cancel this h with an h in every single one of these, which is going to give us the limit as h tends towards 0 of 2x plus h plus 2. Now when we're taking the limit, we're just looking at when h is heading towards 0. So in our equation here, h here, if we just write that as being equal to 0, it'll just disappear. So our derivative, when h becomes 0, is just going to be equal to 2x plus 2. And that's how we find the derivative from first principles of our equation, y is equal to x squared plus 2. Our derivative, dy dx, is equal to 2x plus 2.